Hey guys, I'm Shitich.
My name is Timur, and our project is called Salient Labs. We are an adaptive compression algorithm that uses something called video saliency, which means basically how likely a human person is to focus on a particular part of a video. We use that to isolate certain parts of the video and compress them less than the outer parts of the video, thus making the quality appear the same, whilst the overall file size has diminished rapidly.
Yeah, so the idea here is that when you're watching a video, you're not actually paying attention to the whole clip. You're only looking at certain parts. For example, with this F1 clip, you can see like only certain parts are highlighted because we have a model that basically tells us where a user is more likely to be focusing on at a given time. And what we do here, like what you mentioned, is we basically make sure that these areas are higher quality compared to the areas around it, and thus saving bandwidth, saving storage, ultimately giving you a better streaming experience. Now let's go through the pipeline. So I'm going to click upload here, and I'm going to choose a file and then select a video that we're going to compress and show you guys how our project works. So first things first, our video goes up to S3, and when it's in S3, it returns back a location to that video that we store in MongoDB, so it's easier to push through our pipeline.
Yeah, exactly. And so the first real processing step of our pipeline is the actual saliency model. And like Shita just mentioned, this basically highlights with higher values areas that the human eye is more likely to focus on during watching videos, like these F1 cars here. This is just a heat map visualization we've made to sort of illustrate the effect. And just for some context on what the model is, it's a pre-trained model that we got off GitHub from a research paper. It's called VNet. It's very lightweight, very fast, and very effective, as you can see. And so we just used a pre-trained model and hosted it on base 10, open source, and just accelerated it with some cool GPU-based computing stuff, parallelization. And then from there, what happens is the saliency algorithm will return a JSON of where the focal points in the picture are, like what these red spots in the heat map are, and that gets propagated to the next part of our pipeline.
So now that we have the focal points, I'm going to show you the next part of our process. As you can see, we have a couple different rings here. The middle ring over here refers to one focal point, and as you can see, this is the area where the user is more likely to be paying attention. We play this video. As you can see, it's flickering a bunch. That's because the dogs are moving around. As you can see, there's different dogs, and the rings are overlapping sometimes. And another thing you can notice is that the rings get bigger and it gets more purplish. Basically, the idea here is that these purple frames, these purple bits that you see are going to be dropped when we compress the algorithm. And we're going to interpolate the space around it in order to save that storage and to save that bandwidth for our pipeline.
Yeah, exactly. And yeah, importantly to mention that this is the picture representation that gets sent to the client, and the reconstruction actually happens on the client side, which is why we're able to save so much bandwidth when we're sending this representation along that network chain, right? This is probably, almost 50% less pixels, even though it doesn't look like it. We're dropping almost every other pixel in the outer region, so we're really able to save a lot on throughput in that regard.
Exactly. So to be clear, this is what we're sending to the client, and then the client will then fill in the images with interpolation. All right, let's go back to see if our video has loaded.
Might want to pause here.
Sweet. As you can see, it's loading as the model goes through or the video goes through our pipeline. And at the end, we get two videos right here.
Yep.
Let's wait for it to load. One of these videos is the original video, and then the other video is the one that we have optimized. And as you can see, there's a pretty significant difference between these two in terms of memory or storage. Let me go through the videos. As you can see, this is a normal 1080p of a kid eating a Chipotle meal. All right, it's loading because the Wi-Fi is. Okay, we're going to pause this. And I'm going to show you the video after our algorithm.
Yeah. So as you can see here, same subject. Subject's face is actually, pretty much the same pixel density, pretty much the same resolution. you'll see that the main distortions that happen with video compression that are normal are actually only happening on like the outskirts of the video frame, and that's really because of that mobilization method that's happening in the back, where we're only taking those concentric rings and having less pixel density there.
Yeah. As you can see, we basically maintain pretty good quality while almost dropping 52% of the storage size. And yeah, thank you for watching.